Okay, so one was rate times time equals work. And then we have the rate of one individual times the time of one individual. Plus the rate of the second times the time of the second is equal to work. Uh, yeah, we have the H one. I just want rates dealing with work. And then another one I talked about, you're right, I had to deal with the number. So number times the rate times the time is equal to work, or the number of jobs that can be completed. So those were 3 different rate equations we talked about yesterday. We were working with a problem very similar to this one yesterday, except for we could find the rate of each individual that was given to us. In this example, that's not necessarily the case. Maya could empty 2 bottles in 3 hours. What information can you gather from that? The rate. Her rate would be 2/3. Working with Wilbur, she found they could empty 4 bottles in 3 hours. That's their overall work that they are doing and the time that they are doing it in. What was Wilbur's rate of emptying the bottles? So we still have the 2 people. We're going to have the rate of Maya, time of Maya. So we have the rate of Maya times the time of Maya. So that's how much work she can do, plus the rate of Wilbur times the time of Wilbur is equal to the overall work. Okay, red ribbon week. So what information we know is that Maya can empty 2 bottles in 3 hours. So that's going to be her rate. 2 bottles in 3 hours. But then it says that working together, so when she works with Wilbur, they can empty 4 bottles in 3 hours. That's overall, that's together. We don't have a rate of them together, but what we do know is that how long did they work? 3 hours. So the time that both of them are actually working is 3 hours, and how much work do they get done in those 3 hours? 4 bottles. And what they want to know is, what is Wilbur's rate? So the difference is taking 2 bottles in 3 hours and writing it as a rate versus 4 bottles in 3 hours and realizing that that's individual pieces in your equation. Okay, so you solve. Of course, if you multiply, you're just going to get 2 plus the rate of Wilbur times 3 is equal to 4. Subtract 2 from both sides, and what's Wilbur's rate? 2/3. So he can fill, his rate is 2 bottles. 2/3 of a bottle per hour, if you want to look at that. 2/3 of a bottle, 2/3 of a bottle per hour, or 2 bottles in 3 hours. So just make sure you recognize working together means that they are giving you the time and the work, overall time of work, and not just one individual. Next slide. You want to try this one on your own, or you want me to do it up there? And you're probably right, this is problem number 3 on your homework assignment. So if we go through, we have Sandra and Frederick. So Sandra could build 3 sandcastles in 5 hours. So that's her rate, 3 sandcastles in 5 hours, 3/5 per hour. Working with Frederick, she discovered they could build 3 sandcastles in 3 hours. So together, working for 3 hours, they can build 3 sandcastles. So they want to know what is his rate. So if you solve, you had fractions. You work through it with fractions. And so you better grab a calculator. Oh, yours is there. Did you just multiply by 5? Or you worked with the fraction? You just kept the fraction? Yeah. Okay, just keep the fraction. Oops. That's a subscript. So you get 6/5, and then multiply it by 1/3 or divide by 3. Do it that way, even though that 3 ends up in the bottom. So you get 2/5. Two-fifths sandcastles per hour. So the next type of problem we can encounter, one that I told you about, is work or jobs is equal to number times rate times time. So if we look at this one, we have 5 workers can do 1 job in 8 days. How many workers would it take to do 3 jobs in 7 days? So if we go back to that equation, work is equal to number times rate times time. I don't know what I touched to do that. Let's leave something. So if we start to plug in information, 5 workers, that represents your number, can do 1 job, that's my work, in 8 days, that's my time. What I don't know is the rate, but if I substitute in that information, 1 job can be completed by 5 workers in 8 days. So what is the rate? 1 is equal to 40R. So if I divide both sides by 40, what's the rate? Now they want to know how many workers would it take to do 3 jobs in 7 days. So the rate, I need, if we go back to the equation, work is equal to number times rate times time. The work we want to complete now is 3 jobs. I want to know how many workers will it take to complete it in 7 days. Well, the rate of those workers is 1/40. So you solve. 3 is equal to 7/40th n. So I want to divide by 7/40th. Which means I'm going to take 3 times 40/7, and I end up with 120/7. Now, what's the problem with that? You can have parts of people, but that's not what their logistics is for this. They really don't care, obviously, that you can't have a part of a person, because that's actually 17.14 workers. We can't have a part of a person, so what would I probably say? 18 workers. But here's their justification. Since the use of a decimal number of workers is impossible, it would be necessary to use 18 workers to ensure that it's completed in 7 days. Nonetheless, the answer to the problem, as stated, is 17.14 workers. You better take 18 because 17 is not going to quite cut it. It'll be close, but not quite. So you have to substitute back into the problem. It's like when you have the variation problems, reds vary directly as the number of greens. You put in the information, solve for your constant, and then you substitute back into the problem to solve for another variable. That's the type of problems these happen to be. So we look at this one. Try to minimize it a little bit. It's smaller so I can actually have room to. Right. Mary had 252 gallons of milk. This would feed 42 infants for 12 days. Then 14 more infants were placed in the nursery and 48 more gallons were provided. How long would the milk last now? So we have a number involved. We don't have a rate of just one person and then another infant, how fast they can drink the milk. So we want to look at the problem as work equals number times rate times time. So we have 252 gallons of milk. What piece of information do you think that is? If we're not for sure, let's continue on. This would be 42 infants. What do you think 42 infants is? That's the number. So number is 42 infants. So there's my n value for 12 days. So what's that? That's my time. 12 days is my time. So what do you think 252 gallons is? That's your work or jobs or something like that. So we are going to have 252 gallons of milk is going to feed 42 children or infants for 12 days. Okay, so I need to figure out the rate. How are you going to figure out rate? And then divide. Okay, I'm just going to do this. I'm going to divide by 42 times 12. Is that okay? And the reason for that is because, let's see, 12 goes into 252 times. 12 goes into 25 once with one left over. Oh, 11. Nope, that would be 132. 21. Did I say 2 times or did I say once? It goes in there 2 times to give you 24. So 21. Now I have 21 over 42. And what's 21 over 42? 1/2. So rate is equal to 1/2. Okay with that? Did you get that when you multiplied it on your calculator and divided? Okay, good. Okay. You would? Yeah. You got that? Sweet. All right, so now we want to go back in the new problem or equation. Work is equal to number times rate times time. We know what that rate is, and what's the rate? 1/2. So you go through 1 gallon in 2 days, 1/2 gallon per day. All right, 14 more infants were placed in the nursery. What's my number now? 56, because you want to take the 42 plus 14. So I now have 56 infants. And 48 more gallons were provided. So how much milk do I have now? I'm going to take 252 plus another 48. So how many gallons do you have now? 300. And they want to know how long will the milk last now. So they want to know the time. You're going to calculate that. You can do that, 56 divided by 2. What'd you get?
10.71.
714. What's your label? Days. So it's going to last you 10.714 days, 10.71 days. Now, once again, you could take 0.714 days and do a unit conversion 24 hours in a day to figure out how many hours that is if you want. But 10 and about 3/4 of a day. Okay with that. A little bit different because your work actually involves something besides labor. It was your milk. The gallons of milk. All right. For tomorrow. Up to 15.